Chapter 4-6, the whole point of today's lesson is being able to complete the square, to be able to make two terms into something that can be factored into the same parenthesis. Okay? Solving equations by finding square roots. What is the opposite of power? The opposite of power is going to be roots. Roots and powers are opposites of each other. Now, if I have x squared, how do I get rid of the power of 2? I get rid of it by taking the square root. In other words, the square root and the power of 2 cancel out to give you x. How do I get rid of the square root of x? I'm going to square it, and that's going to give me, canceling out to give you the x. Go, door. Now, this one over here. If I give you x cubed, what happens with x cubed? How do I get rid of that power of 3? The cube root. The cube root. Do you see the power and the root now cancel each other out, and I'm left with just an x? How do I get rid of the cube root?
Cube it.
I'm going to cube it. So when I cube it, that's going to give me x. Do you understand that that's the opposites? They cancel each other out. Powers and roots cancel each other out. Exponents and roots cancel each other out. We all get on that. Now, previously, if we were given this example, 4x squared plus 10 is equal to 46, you guys would bring everything over to one side, set it equal to 0, pull out a GCF, put it to 2 binomials. Agree? That's what you would do. Okay? Well, when you only have an x squared term, and you do not have an x, you just have an x squared term. There's only 2 terms if you were to set this thing equal to 0, right? I don't have a middle term of an x there. Does everybody agree with me? What you would typically do would be that same procedure. However, I'm going to show you a shortcut to that procedure today. Okay? The shortcut is pretend that that's just an x. If that was just an x, what would you do? That was just 4x plus 10 is equal to 46. What would you do? You'd subtract 10. So if you subtract 10 from both sides, I'm going to have 4x squared is equal to 36. Again, pretend that that's 4x. What would you do? You divide by 4. And I'd have x squared is equal to 9. Now, how do I get rid of a power? You take the square root. So I'm going to take the square root of the left-hand side and the right-hand side. I'm going to have x is equal to 3. I have a problem with that. Because what number multiplied by itself gives you 9? 3. What number multiplied by itself gives you 9 again? 3 times 3 is 9. What else? What number multiplied by itself? 1 times 9 is not multiplied by itself. 3 times 3 gives you 9, but what else gives you 9 when multiplied by itself? Negative 3 times negative 3. Do we understand that? So you have to put the plus or the minus here, because you have x plus 3 and x minus 3. And I want to just show you why this thing works. Because if I were to make this thing equal to 0, I have 4x squared minus 36 is equal to 0. If I factor this, I'm going to pull out a 4. That's going to give me x squared minus 9 is equal to 0. To give me x plus 3 and x minus 3. Do we see that? To give you x is equal to negative 3 and x is equal to positive 3. Yes or no? Do we see that?
Yeah.
Which is why you have the plus and the minus concept there. Yes or no? But this, there's a lot to it, isn't it? How simple is this over here?
Pretty simple.
Notice there's only one x in here, though, and it's an x squared term. This is why we can do it. So let's do the same procedure again down here.
Add 5.
So you're going to add 5 to both sides. That gives you 3x squared is equal to 30. Then what would you do?
Divide by 3.
You'd divide by 3. And I'd get x squared is equal to 10. Well, now what would you do to get rid of the power of 2?
Square root.
Take the square root. And when you take the square root of both sides, what do I immediately have to add over here on the right-hand side? Plus minus the square root of 10. No, because there are no factors of 10. Think of it this way. What are all your factors of 10? 1 and 10, 2 and 5. Is that number the same on any of them? So I can't reduce this, can I? Do we understand that, yes or no? Okay, so now let's do this one.
Track 9.
Subtract 9 from both sides. 2x squared is equal to 4. Now what?
Divided by 2.
Divided by 2. X squared is equal to 2.
Square root.
Square root of both sides, and what do I immediately have to do?
Plus or minus.
Plus or minus over there, and that's going to give me the square root of 2. Am I done with that? Yes, because my only factors of 2 are 1 and 2. Do we understand that? So there's no number multiplied by itself to give me 2. So that gives me the plus or minus of 2. Do we all understand that?
Yes.
This is just like problems 1 and 2, and then 12 through 17. This is like 1 and 2 and 12 through 17 on tonight's homework. Any questions over that? Can we do it? Okay. Now, this is where the hard stuff is coming in. But I want to make this very clear. I am taking severe baby steps with this. I mean, like, we're in one of these, we just stood up, okay? And then we wobble back and forth, okay? And we take our first step and we just sit there, okay? We stop. Completing the square is a very complex process. I want you guys to understand this process very well. So for that to happen, I'm going to go very slow in this. Do you all understand that? Okay? Now, how many people in here know somebody whose name is William? Now, I want you to think of all the different names William can go by. The first name can be William. Give me another name.
Will.
Bill.
Willie.
Willie. Will. Billy. Right? We're already up to 6 different names, aren't we? Okay? Now, that means that one person can go by 5 different names other than William. And he'll still answer to it, correct? Well, mathematics is very much the same way. We can have many different forms to represent the same quantity. Do we understand that? 1 can take on 5 divided by 5, 30x divided by 30x, x plus 3 divided by x plus 3. Those are all equivalent to 1. Okay? Now, when you complete the square, our goal is to take 3 terms and put them into one binomial squared. Whenever I take one binomial and square it, that means I have 2 of the same binomials. Do we understand that? That's what squared means. You have 2 of the same thing. Your b value comes by the coefficient of the x. Your c value, if I have ax squared plus bx plus c, do we all understand where I'm talking about a, b, and c now?
Yeah.
Your b term will get you your c term by taking b divided by 2 and squaring it. That is your c term. Your c term is equal to b divided by 2 quantity squared. Now, we're going to practice at this, but before we go on, I want to show you something. If I give you x plus 3 quantity squared, let's say that that's William. Whenever I have x plus 3 quantity squared, what's another way I can write that? What's your brain saying immediately? Whenever I said I have squared, that means how many of those do I have? 2. I have 2 of them. Do we see that? That's Willie. Now, what's your gut telling you should do with that x plus 3 times x plus 3? That is the factored form. So what you want to do, Shayla, is you want to FOIL that. When you FOIL that, you're going to get x squared plus 3x plus 3x plus 9. First outer inner last. Agree? Well, now that person's going to be named Will. Are they still exactly the same person? Yes. They're just different forms. Well, now what's your gut telling you to do?
Put your like terms together.
To combine your like terms to give you the 6x, to give you the x squared plus 6x plus 9. That is going to be your build. What you need to understand is that I need to go from the x plus 3 quantity squared automatically down to the x squared plus 6x plus 9 and vice versa. Your brain needs to go back and forth between those two quantities seamlessly. Okay? 3 times 3 is 9. Inner is 3x, outer is 3x, 3x plus 3x is 6x. Okay, now, your brain needs to be able to get this. Well, how in the world are we going to get this? Well, if I'm given x squared plus 6x plus 9, okay, you would take that middle term, your c value is b divided by 2 quantity squared. Well, what's b? b is going to be 6. 6 divided by 2 is 3. What is 3 squared? 9. Does that equal 9? Does that equal my c term?
Yep.
Yes. Do we understand that? In that example, it worked out. Okay? Now, we're going to use this process over and over and over and over again to create a third term. Do we understand that? So let's go ahead and try it out. I give you x squared plus 16x plus a blank. This is exactly like tonight's homework. You need to fill in that blank with the perfect square term, that c value. So what are we going to use? We're going to take our b and we're going to divide it by 2 and square. So what's b in this case? 16. Divided by 2 gives me? 8. 8 squared gives me? 64. 64 is what goes here. Now why do I want that 64? Because if I try to put this into two binomials and factor this, I can split up x squared to be x and x. I need a positive 64 and a positive 16, bless you, so that's going to be plus and plus. And factors of 64 that are going to add to give me 16? 8 and 8. Does that number look familiar? X plus 8 quantity squared? Where did that 8 come from? It came from the b divided by 2. Did we see that? Yes or no? So by this number turning into a 64, I can make that a pretty little x plus 8 quantity squared. Let's do it again. Yay. Same concept. So what do I do?
14.
I'm going to take my 14 divided by 2 to give me
7.
7, and now I'm going to square that value, and that's going to give me
49.
49. So that 49 goes right here, because if I put this into two binomials, I break down the x squared, that gives me x and x. I need a positive 49 and a positive 14, so my signs are both plus. And what factors of 14 are going to add to give me 4? What factors of 49 add to give me 47? 7 and 7. Where did that number come from? Right there. To give me the x plus the 7 squared. Did you see that?
We have to write that.
All they're looking for tonight is the 49.
Okay.
But I need your brain to connect these dots. Do we understand that?
Yes.
Yep. Okay? We are always going to take b divided by 2 and square it, and that's going to give me my c value every time. That c value is where that 49 is, what that 49 is. BP? You will make it be that. That's the whole point of completing the square.
Yeah.
That's the process I'm going to teach you tomorrow. Actually Wednesday. But I need your brain to start working on this. Why Wednesday? Because we're going to take a time out tomorrow and make sure you guys know how to simplify your radicals.
I won't be here Wednesday.
That's fine. Let's do it again.
18 divided by 2 equals.
Wait, let us try it on our own. Go ahead and try it. Go ahead and try it on your own.
Wait, do you have to carry out the negative?
Go ahead and try it on your own.
Wait, this is different. I lied.
No.
How many of you put negative 18 divided by 2 to get you negative 9? And then you squared that, and how many of you got negative 81?
I never got that because it's just like the 2 nines.
Yeah, so you don't get,
Does it matter whenever you square a negative number?
Yeah.
I'm sorry.
What's the outcome always going to be when you square a negative number?
Positive.
Positive. So does this sign right here matter?
No.
No. So that sign does not matter. So you're going to get 81 here regardless. And the reason why is because x and an x is what we're going to have here. I need a positive, which means plus plus or minus minus. How do I know what it's going to be? It has to be minus minus. That is why the sign matters there. We understand that. And I need factors of 81 that are going to add to give me negative 18. 9 and 9 to give me the x minus the 9 quantity squared. Do we understand that?
I think some of the HW, bro.
Now, this is exactly like all of the rest of your problems, which is going to be 3 through 8 and 28 through 33.
Wait, what?
This is just like 3 through 8 and, what else did I say?
28.
28 through 33. So tonight's homework
Actually,
is this right here. Practice A, 1 through 8, 12 through 17, and 28 through 33 off.
wait, where's 1 through 8?
I am voting.
I don't want to hear it.
I am not going to see the